In this video, we're going to be going over some of the particle alignment and scale parameters we have available inside the Gamebryo RPI tool. I've already got a simple scene set up, so let me go ahead and launch a preview window so you can see what I've got here. This is a really simple scene. It's just particles with the texture applied, so you can differentiate the top of the particle from the bottom of the particle. And I've put a gravity force in here so that the particles are changing direction, which makes it easier to see some of these alignment properties. So if we want to affect the alignment properties, you go to the particle node itself. Underneath animated parameters, there's a drop-down for alignment and scale parameters. Right now, both normal and up are set to camera. This is going to be the behavior you're used to. The particles are always going to render facing the camera with the top of the particle oriented towards the top of the screen. Again, this is what we're pretty used to with most particle systems. Normal alignment, as I mentioned, is the way the particle faces, and we have four options here. It's actually the same options for both. We're going to go through the normal ones first. And the first one here we have is fixed. You'll notice as soon as I did that, that the particles disappeared. Let me go ahead and get to a different side. What's actually going on here, right now these are aligned towards the positive x-axis, so if we look from any direction on the positive x-axis, you can see the particles and you can see that that's the direction they're facing. But if we look at them from the negative x-axis, you'll notice they disappear because we're looking at the backs of the particles, and backsides of geometry are going to get cold. So if you don't want that, if you want to be able to see the particle from either side, go ahead to the Particle System Transform node. The third button over under Add Gamebryo Attributes is going to make that double-sided. Let's go ahead and refresh the scene. And now we can see particles from the positive x-axis or the negative x-axis. So let's go back here. We can orient these other directions if we want. I'm going to orient these towards positive z, so now the particles are always going to be facing up. And if we look at them from the side, you can barely see them. So that's one option you have, is fixed. We can also set these to position, in which case the normal of the particle is always going to be facing away from the origin of the scene. And we also have velocity. This is going to align the normal of the particle along the direction that it's traveling. So in this case, it looks like cards falling down face first. What's actually more commonly useful for this, let's go ahead and set these to camera, and we'll change the up alignment to velocity. So in this case, the top of the particle is always going to be facing the direction it's traveling, while the normal is still aligned towards the camera. You probably also noticed that when we did that, a new drop-down showed up here called Scale Parameters. And this actually lets us control the size of the particle based on how fast it's moving. So to clearly see what's going on here, I'm going to go ahead and pull the rate down so there's fewer particles to look at. And then we'll go ahead through what these are doing. Scale rest and scale limit, UV, you get separate controls for both the U and V directions on the texture. Rest is the size of the particle at speed 0 when it's not moving at all, and limit is the size of the particle that it's going to approach as the speed of the particle approaches infinity. It's also important to note both of these are multipliers, so if you change the particle's size from the emitter node, it will multiply it based on what you put in here. Scale factor, U and V, these control how it's going to interpolate between those two values. So if you put 1 in here, it's going to smoothly scale between 0.1 when the particle's not moving at all and double the size as it approaches infinity. So let's go ahead and put 1 in here. So now you can see particles are starting out at about their normal size, and as they slow down, they're shrinking. And then as they speed back up again, they're growing larger again. And if we put a bigger number in here, it's just going to scale exponentially between those two. So now it only shrinks for a very little bit up here at the top, and then scales up larger, again, much quickly. We can do other things with this as well. You don't have to have it grow larger as it speeds up. We can actually do just the opposite and have it shrink as it starts moving faster. So now they're largest when they're not moving at all, and the faster they move, the more they shrink. Also, you don't have to control these the same direction in both U and V. We can have different values, and in this case what's going to happen is the particles are going to stretch along U as they slow down, and then compress in U and stretch in V as they speed up. So you get these wide, fat particles when they're moving slowly, and these narrow, skinny particles as they speed up. So those are your scale parameters. Let's go ahead and turn that off. You'll also notice that these only show up if up alignment is set to velocity. If we change up alignment to fixed or position or any of the other options, we don't get that anymore. And again, these are the same as camera, except this time it's controlling which way the top of the texture is facing. So if we change the up direction to the x-axis, you'll notice that now the top of the particle is always pointing towards positive x, wherever that happens to be. And we have position. This is going to keep the top of the particle pointing away from the origin of the scene. So those are the alignment and scale parameters for normal sprite particles. You can also use these with mesh particles. Let me go ahead and open up a scene I've prepared for that. And let's go ahead and launch the preview window so you can see what's going on here. Now in this case, I just have, it's pretty similar, except instead of emitting sprite particles, I'm emitting mesh particles. This is just a cone with some vertex colors so we can see how this is oriented. Let me go ahead and show you the original mesh so you can get an idea for what's going on here. As you can see, the tip of the cone is oriented towards positive X, and then this little fin here is oriented in positive Z. So let's go ahead and hide that again and pull up my alignment. Right now I have this set for the normal to be aligned along velocity. Again, normal for a mesh particle is the positive x-axis, and the up alignment for position up is the positive z-axis. And these are the settings you would want to use if you want a particle to be aligned along the direction it's traveling, like with a sprite particle. And again, we can change these to whatever we want. We can set that to be fixed. Sometimes vertex colors will get lost in the shuffle. And in this case, the positive x-axis of our mesh is always going to be pointing along the positive x-axis. We could change that to the positive y-axis, which is going to orient these along that direction. And you'll still notice that the little red fin, the up alignment of this, is always going to be pointing away from the origin of the scene. We'll get to a better vantage point so you can see that. So that's how these interact with mesh particles as well as sprite particles.